Here we go. All right, your formal lab is on the spring lab. The spring lab purpose is to determine the spring constant of a spring. The materials, you're going to use a simulator, which will give you a spring, some kind of stand, masses, and a ruler. I'm going to show this procedure, and then I will upload a video of me going through the procedure. I'm actually recording it right now, so that way you can go ahead and review this if needed. The simulator, you'll click here to run the simulator, which I will show you how to in a moment. I'll talk about the tips after I go through the simulation, as well as the questions. The grading for the lab is found here in this rubric, and the due date is Friday, November 20th, 2020 at 11:59 p.m. Unlike the last one, to submit this one, you're going to email it to me, and you'll CC your entire group, so that way everybody knows that it's been submitted. I will not be taking the argument of, well, my lab partner screwed up and did not submit the lab, so it's not my fault, and I'm not taking the 20% late penalty. Well, one, you are taking the penalty, and two, it is still your fault because it's your responsibility as much as it is your lab partner's to ensure that it is done. Reminder, divide and conquer doesn't exactly mean what you think it means. It does not mean to divide this and conquer the material so you get through it faster. Divide and conquer is actually something that's designed to say divide your enemies so you can conquer them easier, because when they're not working together, that's when flaws happen. Same thing happens with the lab report. If you try and divide up the work, that's where the flaws come in. That's where the arguments come in. Don't do it. Now, how are you going to be graded on this? So that's where the rubric comes in. This is all I look at. And I go through this list. Some people last time decided, I don't want to do a diagram. Okay, you forfeited those points. Can't help you. Some people didn't want to do an equation in real terms. You forfeit those points. Some people didn't want to talk about the y-intercept. You forfeit the points. If you don't meet all the content here on the rubric, you can't get that score. So this is what I use to grade you. Check it. Grade yourself. Think about how you would do. Now, you'll notice that some of these things might sound a little bit strange to you. Say, for example, equation written in real terms. There's two resources to help you, and they're right here, Formal Lab Information. You go onto this tab, and there is a guide for writing it. So if you're looking for equation in real terms, for example, you scroll down here, and real terms, it talks about it here in the graph. This is part of your graph and analysis. Let's say you read that, you still need a little bit more clarification. Here's an example lab report that's done for you. And in this example lab report, you would scroll down and you see the equation in real terms shown here. So you have an explanation of how it's done. You have an example of it being done. You should be able to figure it out when you come into your rubric to see, I need an equation in real terms. What does that mean? Let's say you needed issues with a procedure. Well, information on how to do a procedure is here. An example of a procedure is shown here in the example lab, so you can get an idea of the amount of detail. Notice how we're doing it in first person. We have diagrams involved to help you out. This is how you're being graded. If pieces are missing, can't help you. All right, the lab itself, you're going to determine the spring constant of a spring. So we're going to go into the PhET simulations. You'll click on lab. There's a lot of stuff here. You don't need all of it. In fact, there's very little that you do need. From the right side, you need to take the ruler. This here, spring constant, if you'll notice on the rubric, it says list spring constant 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You set it to what you want. I'll pick 3. Why? I don't know. Who cares? Now, we are not concerned about the length of the spring. That's not what X is. X is how much the spring is stretched. So I'm going to put the ruler to set it zeroed out right here next to the spring. This dial here changes the orange mass to whatever value you want. So I'll say 222. I hang it on here. It keeps bobbing up and down. I want that to stop because it's annoying. So I click the stop button. That means it's done oscillating. I can take a look and see what is going on with my lab to give you the detail of what you're looking for. You are looking to see how much the spring has stretched. So right about here. This looks like just over 41 centimeters. Notice that I don't care that the spring comes down to 64 centimeters, or the mass comes down to 64 centimeters. That's not important to me. The only thing that's important to me is how much has the spring stretched. As I go to record my data, I would have mass. That's my independent variable. And I want it in kilograms. So this is 222 grams. I'm not putting 222, I'm putting 0.222 because I want it in kilograms. And then displacement in meters. So I see this comes down to, I'll call this 41 centimeters. I'm not putting 41, I'm putting 0.41 because I'm converting it into meters. So I had 222 grams at 41 centimeters, converted to 0.222 kilograms and 0.41 meters. That's the first data point. Come back and change the mass to something else, stop it, do it again. That's how I collect the data. Now, some tips for you. You are measuring how much a spring has stretched. That does not include the length of the mass, just like I showed you. The tools are measuring things in grams and centimeters. You want kilograms and meters. Make sure you convert. The more data points you have, the better the results. I recommend 10. If you make a huge error, you redo it. You don't write it off. You want to make sure you identify the independent and dependent variables. I just did that for you. Mass is independent. Displacement is independent. And remember that the data that you're collecting serves only one purpose, and that's to make a graph. Your analysis is going to come from the graph. That's why I have you get the slope of the line. That's why I have you put the slope of the line in real terms. Your 5 questions for analysis. The first question talks about how you're not able to directly measure the spring force. Just like in the example problem, I didn't know what the spring force was, but I knew it was in equilibrium because another force was acting on the spring and it caused the two to cancel out. What is that force? That's how you answer question 1. That's how you figure out what the spring force is. Question 2 is a straightforward question. Once you get the graph done, it's asking you what's the relationship. So is it linear, quadratic, exponential? If it's exponential, is it exponential growth? Is it exponential decay? If it's linear, is it a positive slope, a negative slope, no slope? The third question is kind of expanding on to what you did. Imagine you used a spring that was more loose. How would that change the values of the displacement if you used the same masses? 4, what variables make up the slope? Do not have the word mass in there. Do not have the word displacement in there. Mass is the independent variable. Displacement is the dependent variable. They're not a part of the slope. Some other things are. Is the slope the spring constant? No. Is the slope helpful in finding the spring constant? Yes. Is the spring constant part of the slope? Yes. That's how you're going to find the spring constant. Question 5, the springs that you used were stretched. How could you do this if it was compressed? Or how would the graph change if it was compressed? So what I want you to think about in that particular example is, let's go ahead and say you repeated this experiment, but you did it with a spring here on the ground, and then you took the mass and put the mass on top, compressing the spring. How would that change the graph? I want you to recall that mass is always greater than or equal to 0. You can't have a negative mass. This will help you determine how the graph changes. Displacement, though, displacement can be, it can be positive and it can be negative. So that will be different. In this case, the displacement the spring length has decreased. How is that going to impact the graph?